Right, hello and welcome to another lesson. This one is called inequalities. And I think this was part of lesson 16, and I'll chop it up into two parts. So the first part is inequalities, and the second part is going to be drawing graphs, straight line graphs. So, inequalities. Now, what's inequalities? Well, we know we've got equal signs, haven't we? So 4 equals 4, that's fine. But what happens when we have 4 is this one? This is less than. So 4 is less than 5, and 5 is more than 4. So depends on whether you're reading it left to right or right to left. It can either mean less than, points down to the smaller size, and it opens up to the bigger ones. Yeah. Now, less than, more than, and it can be around the other way as well, can't it? It can be 5. No, I'll do it with the same numbers. I can't do it with the same numbers because the sign wouldn't be correct. So we can read it the other way around. So we can do 5 is more than 4, yeah, or 4 is less than 5. Same thing. Now, so if we have x is less than, say, 3, then possible values of x, integer values, not going to integer, won't do fractions and decimals and things yet. So x could be 2, 1, 0, minus 1, minus 2, etc. If x is more than 3, then the possible values of x would be 4, 5, 6, 7, 8, and so on. Good stuff. Yeah. Now, there's another sign to get hold of, and this is the more than or equals to. So if x is more than or equals to 5, more than or equals to, so we've got more than or equals to. So possible values for x here, it could be 5 because it could be equal to 5, and then it could be 6, 7, 8, 9, 10, etc. Now the only difference between the simple more than and the more than equals to is then we include the number 5. If we just had x is more than 5, then we wouldn't include this number, we just start with 6, 7, 8, 9, 10. So there's a difference. And of course we can have this the other way around. X is less than 4 or equals to. So this is less than or equals to. So possible values for x here, it could be 4 or it could be anything that is less than 4. Yeah, so hold on. Now we're going to represent these on an inequality line, a number line basically, line, L-I-N-E, inequality line. So how do we do this? So what we're going to do is we're going to have a simple number line, 1, 2, 3, minus 1, minus 2, and minus 3. So we're going to represent in blue, because I'm going to do a couple on the same one, save a bit of space, yeah? X is less than 2. So a less than sign is represented by a circle like this. And anything less than 2 would be a value of x. So we just do an arrow to the left. It doesn't matter whether it goes to the end, halfway, it's the direction that's important. And x is more than minus 1. So we go above the minus 1 and go the other way this time. Yeah. Okay, now, what about the other things, the other ones. So let's do 0, 1, 2, 3, minus 1, minus 2, and minus 3. So again in blue we will go x is less than or equal to 2. So again we go above the 2, and this time because it's a less than equals 2, we colour in the dot. Yeah, colour in the dot. More ink in the sign, more ink on the dot. Now it's less than, so we know it starts from 2 and goes less than. And we do the other one, the other way, is x is more than or equal to minus 1. So we go to the minus 1, and this time we do a coloured dot, and we go the other way. So there's the 4 combinations. Right, so when we were doing, what were we doing such a long time ago? We were doing grouped frequency tables where we were measuring people's height. And we have x for the person's height, and we had sort of 1.2 meters to 1.4 meters. Yeah. So now x is in the middle of these, and we use both these signs, so we can represent this on a number line, but we won't use decimals. So let's go to our 1, 2, 3. It's nice drawing these. 1, 2, and minus 3. So we're going to represent a combination now. We're going to have minus 2x and 1. Okay, so we go to the minus 2 and we put an open dot here. We go to the plus 1 and we put a closed dot here and join them up together. And x can have any value in there. Now all the integer values of x in here will be, can't be minus 2, can it? It must be minus 1, 0, and include 1. And we do it the other way around. We'll do minus 3x and 2. Now, so we go to minus 3 and we do a closed dot there. We go to the 2 and do an open dot there. And we link the 2 together. Now, all the possible values of x, integer values, are going to be, it could be minus 3, minus 2, minus 1, 0, or 1, but not 2, because it's less than 2. Okay, so we've got all that done, so let's find out what we need to do next. What do we need to do next? Now we're going to use this as that little part is done. Now the other part is very similar, almost the same to linear equations. So when we had a linear equation, we could have had something like 2x minus 4 equals 10 with an equal sign in the middle. And so we would add 4 to leave us 2x equals 14, divide by 2, x equals 7. Now when we have a linear inequality, yeah, it would just look like this. 2x minus 4 may be greater than 7, but greater than 10. So again, add 4, 2x greater than 14, divide by 7, x is greater than, divide by 2, sorry, x is greater than 7. So possible values for x here would be 8, 9, 10, 11, 12, and so on and so forth. Yeah. So it's just the same as a linear equation solving, except we've got the sign. It doesn't matter what the sign is, which way round it goes. Let's do 2x plus 4, 24. So we take away 4, so 2x is 20. Divide by 2, x is less than 10. Possible values 9, 8, 7, 6, 5, and so on. Right. Now, there is one thing that does is there. It's not designed to catch you out, but it could be. Is when you divide by a negative, you have to flip the sign. Okay, let's have an example of this. So we've got 9 minus 2x is 15. Now we need to get rid of the 9. That's a plus 9, so we subtract 9 from both sides, but that leaves us minus 2x. Subtract 9, that's 6, yeah? Now we need to divide by minus 2. So that leaves us x, and 6 divided by minus 2 is minus 3. Now, because we divided by a negative number here, when we actually do the division, the sign flips the other way. So remember that bit, yeah, where you've got a dividing by a negative number. It's the only time that it can catch you out, yeah? So then we move on, as we did in linear equations, just by having an x on both sides. An x on both sides. So now we get rid of the smallest number of x's because they're both positive. So take 5x away. Take 1x away, sorry, that leaves 5x plus 7. Why have I got x's and x's? It shouldn't be an x. Shouldn't be an x. 5x plus 7 is 22. Subtract 7. So 5x is 15. See, all I'm doing is just copying this sign, making sure it's the right way around. Divide by 5. 15 divided by 5 is 3. Okay, so that's exactly the same as linear equations, but now the difference changes a little bit when we have, like the layout in the group data tables, where we have an x in the middle. Now, if we have just 5x 15, we know that all the possible values of x would be in between 6, 7, 8, 9, 10, 11, 12, 13, 14, yeah? So we could do that on a number line and have 5 there and 15 there, and x would be all the integers in between. That's okay because we've got a single x in there, but up here we've got 2x in the middle, so we need to employ some trickery to get that simplified. Now, because this is 2 times x, if we divide everything by 2, then we're going to get a single x in the middle. Now, when you divide the middle by 2, you have to divide everything, all 3 parts. So that would become 2.5, and that would become 7.5. So on a number line, it would look like this. I'll only do the numbers there. So this would be 2.5, and this would be 7.5. If we have 31, 3x plus 1, and that and 49 there. So what do we do here? Now we've got to get a single x in the middle. So first thing to do, like all linear equations, is just get rid of this 1. So we take 1 away from everything. So that would be 30, 3x, and 48. Now we have to divide everything by 3. So this would be 10x, 16. And on the number line, we'd have this. We'd have 10 there, open dot, and 16 up there, close dot, and there's the thing on the number line, and all the possible values of x as integers would be 11, 12, 13, 14, 15, and including 16. And what I'm going to do is I'm going to stop this one here because I'm going to use the graphical inequalities as part of drawing the straight line graph. So I'll put those all together in the second part. So let's stop this.